Well, students, we have talked about static electricity and we've talked about electric forces, and now we're going to see that demonstrated a little bit with something called induced electric charge. Our goal today for this video is to be able to explain how a charged object can induce an apparent electric charge in a neutral object. So you've probably seen stuff like this before, where like tinsel from a Christmas tree or a plastic bag or a piece of tape just keeps sticking to things and you can't get it to stop. That would be an example of kind of an induced electric charge, where one object is charged, the other one's neutral, but somehow they're still sticking. So let's talk a little bit about that. So before we explain and do a little demonstration, here's a balloon using my extra long hair and remembering from the previous video that something like rubber does a pretty good job of taking negative charges, and something like human hair is pretty good at donating negative electric charges or electrons. We're going to use my hair to charge up the balloon. And this doesn't take very long. We're going to add plenty. So we're going to do this for a little bit. 5 or 10 seconds is pretty good. Okay, now my hand, which is not charged, will now stick to the balloon. So you can kind of see there that the balloon's not resting on the ground, and it is stuck quite easily to my hand, even though my hand is not statically charged. So how is that happening? That's kind of mysterious. So let's take a look. So what we've done is the rubber has acquired some negative charges from my hair. My hair sort of released some electrons to that. So the balloon, please don't misunderstand, it still has protons there, it just has more negatives than positives. So we're just going to show that it has extra negative charges on there. Now, this wall or line represents my hand, and it has both positive and negative charges. Again, there's way more than this in there. This is just to show in a diagram. Now, as we bring this closer, the positive charges are stuck in place. Those are protons, they're in atoms, they're locked in place in the solid. The electrons are a little bit looser. Some of them can actually move. On the outside of the atom, they can be pushed around. So those positive charges stay put. Some of those little negative charges get pushed away. So now the positive charges on my hand or the wall are much closer, which now creates a force between like charges that holds that balloon quite strongly in place, as you guys saw in the video. So the key idea behind induced static charge or electric charge is that electrons or negative charges can get pushed around a little bit. And when that happens, we can see things stick to each other, where if these electrons were also stuck in place, then it would remain neutral and the balloon wouldn't stick. But since these get pushed away, the positive charges are much closer than the negative charges, therefore the attractive force is much stronger than the repulsive force from the negative charges, and they stick together. And this also explains why lots of plastic things, plastic bags, tape, can end up sticking to things, even though maybe only the plastic thing is charged. Okay, thank you for watching that demonstration and explanation, and I hope you enjoyed the video.